All right, we're going to continue multiplying two binomials together, but in these next three problems, notice that we have a binomial that's squared. Right? As we're doing this squaring, we want to make sure that we avoid just squaring each term. We want to make sure that we think about this as multiplying two binomials. So the best way to do that is to go ahead and start by rewriting our problem. So x plus 5 squared really means x plus 5 times x plus 5. X minus 4 squared really means x minus 4 times x minus 4. 2x plus 5 squared really means 2x plus 5 times 2x plus 5. Right? So we're not just squaring each term that's inside, right? We're squaring our entire binomial. Right, now that we have all these written out this way, we can do these exactly like we did the first part of this example that we just finished. So we're going to distribute this x. X times x is x squared. X times 5 is 5x. Then we're going to distribute our 5. 5 times x is 5x. 5 times 5 is 25. Again, we're going to combine our middle two terms here. We get x squared plus 10x plus 25. All right, so for f, again, we start by distributing our x. X times x is x squared. X times negative 4 is negative 4x. Now we're going to distribute our negative 4. Negative 4 times x is negative 4x. Negative 4 times positive 4 is positive 16. Right, again, we're going to combine our middle two terms. X squared minus 8x plus 16. Right, one more. 2x times 2x. 2x times 5, we're going to distribute that first 2x. 2x times 2x is 4x squared. 2x times 5 is 10x. Now we're going to distribute our 5. 5 times 2x is 10x. 5 times 5 is 25. Again, we're going to combine our middle two terms. And we get 4x squared plus 20x plus 25. Right. Now, as we're looking at these, again, in the last example, we talked about kind of looking for patterns for signs and things like that. Not only do we see the same thing that happened in the last example, all of these, since we're squaring the exact same thing, our binomials have the same sign. That means that our last term for all of these is positive, just like it was in example A and B on the previous page. But looking at this a little bit further, notice that those middle terms, those terms that we combined, were identical. Right? So that's something else that we should notice. Another thing that we should notice is we should notice that our first term and last term in all of these are all perfect squares. Right? So what we're going to do, again, we're going to kind of generalize this a little bit. All right. So these are what we refer to as perfect squares. Right? These are perfect square trinomials because our answer is a trinomial. Because we squared the original binomial. And if we look at our kind of pattern for our answer, this first term that we have is actually that first term of our original binomial squared. Right? X squared, well, that's our first term. X squared, well, that's our first term. We square 2x, right? So we're going to square both our number and our variable. That gives us 4x squared. So what that means is our first term right? And our answer is our first term squared. Right? And then if we look at this last term, notice that this last term is also a perfect square. Right? 5 squared gives us 25. Negative 4 squared gives us positive 16. 5 squared gives us 25. Right, so our last term is positive. Right, and we square that. Now in the middle, depending on what sign we have in our original binomial, we could have a plus sign or a minus sign. Right? And what we're going to do is kind of a way to kind of think about this as a shortcut. If we take the product of our two terms, so our product of x and 5 times x gives us 5x. And then we're going to double that, right? Because what we have in the middle is the same. We double 5x, we get 10x. We double our product, which is negative 4x, we get negative 8x. We double our product, which is 10x, because 2 times 5 gives us 10. We double 10x, we get 20x. So what we have in the middle here, right, is double the product. Right, now what this does is it generates some formulas for us. Right? So this gives us a couple of general formulas. A plus b squared. Right? So we're going to square our first term, a squared. We're going to double our product. Well, a times b is ab, so we're going to have 2ab. And then we're going to square our second term, we get plus b squared. If we have a minus sign in our original problem, and we're going to square our first term, a squared, double our product. Well, now our product is a negative ab, so we double that, we're going to get negative 2ab. And we square our last term, and it turns out to be positive b squared. Now, if we go back to the notes on the previous page, notice that this squaring a binomial, right, these formulas are given here, right? We generate these formulas in example E, F, and G. Now, you don't need to memorize these formulas. Again, one thing that I'm giving to you is stuff that could be useful for you next semester. Right? You don't necessarily need to memorize these formulas because we can do these problems just as we did. Right? We just used our distributive property twice as we went through them, and we got the correct answers. If you choose to use your formulas instead for your perfect squares, that's totally works. It's just kind of up to you as you're going through the problems, whatever you feel most comfortable with.